Hello and welcome to the base strength tutorial. During this tutorial, we will review how to determine base strength in a given set of bases. As defined by Bronsted and Lowry, a base is a substance that accepts a proton, H+, from another species. The general reaction for a base with water is the following. In this reaction, a stronger base will accept more protons from water than a weak base. Note, for a base to accept a proton, in general, it must have a lone pair of electrons to form a bond with H+. Therefore, when determining which of the structures is a stronger base, we want to ask ourselves, how available is the lone pair to bond to a proton, H+? In the determination of the stronger base, we want to look at three things. First, we will look at the electronegativity of the atom with the lone pair electrons. The more electronegative the atom is, the less available the lone pair electrons for forming a bond to a proton. For example, we'll look at water and ammonia. First, we should add the lone pair electrons on the structures. When we look at the periodic table, we note that oxygen is more electronegative than nitrogen. Thus, the lone pair electrons on the nitrogen are more available to form a bond to an H+, and thus ammonia would be more basic than water. Note, many students will initially think that water is the stronger base because the water molecule has two sets of lone pair electrons, whereas the ammonia molecule has only one set of lone pair electrons. However, you must remember it is not the number of electron pairs, but the availability of the electrons to be donated to a proton that determines the strength of the base. The availability of electrons for donation to a proton can also be affected by the presence of an electronegative element in the vicinity of the basic site. For example, compare ethoxide and 1-chloroethoxide. The electronegative chlorine atom in the 1-chloroethoxide can pull electrons towards itself through the covalent bonds. This will make the electrons on the oxygen in the 1-chloroethoxide less available to form a bond to H+, and thus 1-chloroethoxide will be the weaker base. This is called the inductive effect. Another factor that influences the base strength is the size, as in atomic or ionic radius. If we are comparing bases in the same family, we can use this property to determine the relative base strengths. For example, let's consider the following bases. Our two ions are hydroxide and hydrosulfide. Both of the ions have the same number of valence electrons and the same overall charge. The periodic trends tell us the atomic radius for sulfur is larger than the atomic radius for oxygen. Therefore, in sulfur, the valence electrons are more spread out. This results in the electrons being less available to be donated to form a bond to a proton. This makes hydroxide the stronger base. The last factor to consider when looking at base strength is resonance. If the lone pair electrons on the basic atom can be delocalized through resonance, then this will decrease the availability of the electrons to be donated to a proton and make it a weaker base. For example, we have two structures, aniline, also known as benzenamine, and cyclohexanamine. The difference between these two molecules is the nitrogen in aniline is adjacent to a carbon-carbon double bond. Thus, the electrons on the aniline nitrogen can be delocalized over the benzene ring. Here is an example. We can see that there are several resonance structures for the aniline and no resonance structures for the cyclohexanamine. Therefore, the lone pair electrons in aniline are not as available to be donated to an H+, and aniline is the weaker base. Thus, cyclohexanamine is a stronger base. I think it's time for you to put those base strength skills to good use. In order to practice, we will have you pause the video, draw the structures, identify the stronger base, and then play the video again to check your answers. We will begin with the following molecules. Please pause the video at this time, and good luck. Welcome back. We are comparing the base strength of methane versus ammonia, the ability for the molecule to gain a proton. If methane were to gain a proton, the carbon atom would have 5 bonds, which would break the octet rule. Therefore, this would not be a strong base. The ammonia molecule has a nitrogen as a central atom, with a lone pair of electrons on the nitrogen atom. This lone pair of electrons makes it possible for the ammonia molecule to accept a proton, and hence the ammonia molecule is a stronger base. We have some more molecules for you to practice with. Our next practice molecules are water and hydroxide. Please pause the video, write down the structures, find the stronger base, and then play the video to confirm your answers. Good luck, and please pause the video at this time. Welcome back. Let's go over the answer. In both of the structures, we have the same central atom, oxygen. The water molecule has an oxygen atom bonded to 2 hydrogen atoms with 2 sets of lone pair electrons, and the hydroxide ion has an oxygen atom bonded to 1 hydrogen atom with 3 sets of lone pair electrons. The strongest base will be the base with the most available lone pair to accept a proton, H+. The hydroxide ion has a negative charge and has extra electrons. Therefore, its electrons are more available to be donated to accept a proton than water, which is neutral. I have one last question for you to practice on. Again, please pause the video, write down the structures, determine the stronger base, and then play the video again to verify your answer. Here are the ions. Please remember to identify the stronger base. Good luck, and please pause the video at this time. Welcome back. Let's check your answers. Both of these structures are anions, meaning a negatively charged ion. The methoxide ion has no possible resonance structures, but the acetate ion has another resonance structure. Because the acetate ion has a resonance structure, its electrons are delocalized and thus less available to be donated to a proton. This decreases the base strength, and therefore the methoxide ion will be the stronger base. Thank you so much for watching this tutorial. Please feel free to watch the other tutorials, and good luck.